Hello everybody. In my this second video of atomic physics and molecular physics, first let us discuss about spectral notations, right? Spectral notations. So already in my last video I said that L starts from 0, the orbital quantum number. 0, 1, 2, 3, 4, 5, so on. And it is denoted by the letters, the notation 0, S, P, D, F, G, H in such a way. Right? Now here, these spectral notations first are used for writing electronic configuration. Right? So how we will write the electronic configuration? For example, let us take sodium. Sodium, how many electrons it is having? 11 electrons it is having. Right? Now how we will write means, the first point, the value of total quantum number. The value of total quantum number n is written as prefix to the letter representing L values. The second one, number of electrons with same N and P values are written as upper right hand side letter representing L value, right? Representing L value. Okay. Now how means? Now for example, we took sodium with 11 electrons. Okay. So now here electronic configuration, how we will write 11 electrons means, this is nucleus of the sodium. The first orbit n equal to 1 or k orbit. How many electrons will be there? 2n square. 2 electrons will be there. Following 2n square. N equal to 1, 2 we will substitute. In second orbit, how many electrons will be there? 2 square. 4 into 2, 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Right? And in a third orbit, how many electrons will be there? 2 into 3 square. 3 into 3, 9, 9 twos are 18 electrons will be there. So, first orbit is the one single orbit. Second orbit is divided into two subshells. That we write it as 2s, 2p. And first one we will write it as 1s. Third orbit is divided into three subshells, 3s, 3p, 3d, right? So s orbital takes 2 electrons, p orbital takes 6 electrons, d orbital takes 10 electrons, right? So now if we take the sodium with 11 electrons, so first s orbital takes 2 electrons. First electrons will be filled up in the first orbit. Right? Now here first we will write principal quantum number. Right? What is the number of principal quantum number here? 1. And what is the subshell or shell here? Only one shell, that is S will be there. How many electrons are present? 2 electrons. So what we will do? To the L value. Right? Now this is L equal to 0, L equal to 1, L equal to 2. L equal to 0 means S orbital. L equal to 1 means SP. L equal to 2 means SPD. Right? So This is L value. Now next, number of electrons are written as upper right hand side of L value, and the quantum number is written on the as a prefix to the L. Right? Now next, how many electrons are remained here? Out of 11, 2 electrons went into the first orbit. Okay, so 9 electrons are remained. The remaining 9 electrons second enter into 2s, 2p. S takes 2 electrons. P takes 6 electrons. So P and S are L values. Number of electrons are written here, and the orbit number is written in front of this. Behind this L value. Right? Now next, how many electrons completed? 6, 7, 8, 9, 10. More, how many electrons remained? 1. So now that will enter into TS, 3s. How many electrons are there? 1. So in such a way, by using the spectral notations, we will write the electronic configuration. Right? Now next, the spectral notations to denote the total orbital momentum of atom we denote with capital L, and the notation same. 0 means capital S, but capital letters S, P, D, F, G, so on. Right? So now here, how we will write the spectral terms? Let us see how we will denote the spectral terms. Right? First, the value of total angular momentum in quantum numbers, what I said? The summation of L and S. So, L plus or minus S, or the total angular momentum gives the combination of L and S. Right? So, now here, first, the value of total quantum number. The first point, the value of total or angular momentum is written as subscript at lower right of letter representing L value. Right? The second one, the number of possible values of J. Possible values of J are written as the subscript at upper left hand of letter L. Right? So, for example, I am taking L equal to 1. S values will be either half, plus half, or minus half. So, now here, first let us write the multiplicity. Multiplicity. So, 2, S means half plus 1. 2 cancels. 1 plus 1. Multiplicity is 2. Right? So, now next, let us write J value. L plus or minus S we are saying. Right? So, first for plus, 1 plus 1 by 2, what we will get? 3 by 2. 1 minus 1 by 2, what we will get? 1 by 2. Now, how we will write these spectral terms? First point, what he is saying, the J value is written as subscript at a lower side of L value. Here, what is the L value? 1 we said. 1 means what? P. So, first you write P. Right? Here L equal to 1 means nothing but spectral notation P. Now, next it is written as subscript at lower right hand. This is the right hand, now lower right hand. 3 by 2. J value. And here another J value. 1 by 2. Next, the possible J values. This one, multiplicity, is written at upper left hand, means here. So, spectral notation 2p 3 by 2, 2p 1 by 2. Right? In such a way, we will write the spectral notations. Here now, let us discuss about coupling schemes. Right? Two types of couplings will be there. One is LS coupling, other is JJ coupling. So first let us discuss about LS coupling. So such kind of coupling, we also call it as normal coupling. Okay. We also call it as Russell-Saunders coupling. Russell-Saunders coupling. Right. In this coupling, the individual values of L of each and every electron combine to give the total angular momentum, right? Such as if we take some number of electrons, if L1, L2, L3, so on are the angular momentums, orbital angular momentums of that particular electrons, then the summation of these, such as L1 plus L2 plus L3 plus so on, gives the resultant angular momentum. Similarly, the spins of individual electrons, the summation of spins of individual electrons gives the resultant summation. Okay, summation of that particular spin vectors. Now, the combination of this L and S give rise to the LS coupling. The combination of L and S give rise to the LS coupling. Magnitude of L is written as under root L plus 1 H by 2 pi. So this is magnitude of L. Magnitude of L. Okay. Where L we call it as total orbital quantum number, and can take all the values between maximum and minimum values corresponding to L1, L2, so on. Now let us find out these maximum minimum values corresponding to L1, L2, L3, so on. So for this, let us take an example of 3p 3d electrons. Right? Now we know that L0 means the spectral term S. Now L 1, 2, 3, S, P, D, F. This we know that. Already now only we completed this. The spectral terms. So now LP means what? L1 is equal to 1. Now L2 is equal to what is here? D. D means what? L equal to 2. And what will be the maximum value? Okay. Maximum value will be 2 plus 1. That is 3. And what will be the minimum value? Minimum value 2 minus 1. That will be 1. Okay. So now here the possible values will be, how we will write? Minimum is 1. Maximum is 3. So possible values are 1, 2, 3 are the possible values. Let us take another example such as 2p, 3p, 4d. Now p means what? 1. So L1 equal to 1. Next also we are having p. L2 is equal to 1. Now d means what? 2. Now first let us write the maximum values. Right? The maximum values means what? 2 plus 1 plus 1. 2, 3, 4. And next let us write the minimum values. So minimum value is how we will write 2 minus 1 minus 1. So 2 minus 2, that is equal to 0. So possible values how we will write? So minimum is 0. Maximum is 4. In between what we will get? 1, 2, 3. So possible values are 0, 1, 2, 3, 4 are the possible values. So in such a way we will find the maximum and minimum values for this L orbital quantum momentum. Now let us move for the value of S. How to find the value of S? The value of S, it depends upon the number of electrons. Depends upon the number of electrons present there. Now, if two electrons are present, now how will be the spin? Either the spin will be in the same direction, right? Now parallel to each, or the spin will be anti-parallel to each other. So S1, S2, S1, S2. What is the value of a spin? Plus or minus half. So now here S1, both are in same direction, half plus half. How much it will be? 1. Here half minus half. How much it will be? 0. So the possible spin values for the two electron system is 1 and 0. Similarly, if we take 3 electron system, either the all electrons may spin in same direction, S1, S2, S3. So in such a position, what will be the spin value? Half plus half plus half, that is equal to 3 by 2. Now next, either two electrons will be in same direction and third electron will be opposite to that. So now here what will be the spin value? Half plus half, that is equal to 1. Now here in opposite direction, so minus 1 by 2. The spin value is 1 by 2. Now next, if we take the 4 electron system, then okay, so the spins will be either in same direction, S1, S2, S3 and S4, right? What will be the spin value? Half plus half plus half plus half, that is equal to 2. Now next, either it may be 3 electrons will spin in same direction, 1 electron may be opposite to it. So what we will get? Half plus half plus half, 3 by 2, minus here in anti-parallel direction or opposite direction, minus half. So what we will get? 2 by 2, 1. Now next, either two electrons spin will be in same direction and other two electrons will be opposite to these directions, right? So now here the possible spin values, half plus half 1 minus half plus half 1, that is 0. 2, 1, 0 will be the possible spin values. Okay. Now next, let us find out how to calculate the spectral terms using this LS coupling. Okay. So we are calculating the spectral terms using LS coupling. Right. Now the spectral terms, let us take an example of 4p, 4d. Now here P and D are there, right? Now again I am writing 0 means S, 1 means P, 2 means D, 3 means F. Okay, the L value and the spectral notation. Right, these are the spectral notations. Now first, the spin value is either for both half only, S1 equal to S2 equal to half. So now the maximum value of this spin, half, first I am writing the maximum value, half plus half, 1. Next the minimum value, half minus half, 0. So the spin values will be 0, 1. Right, clear? Now next, let us write the L values. Okay. So first, the L maximum value. So P means what? 1. D means what? 2. So 1 plus 2, 3. Now minimum value. 2 minus 1, 1. So the possible values. 1, 3. Minimum, maximum, and in between 2. 1, 2, 3 are the possible values. Now first, let us write for singlet terms. So first I am taking S is equal to 0. Now for L equal to 1, what will be the J value? J equal to L plus or minus S, no. Either you do plus, you will get 1 only. If you do minus, you will get 1 only. 1 minus 0, 1. So the J value will be 1 only. So now here, L is 1 means what? Spectral term P. And total J value, we will write as subscript on right hand side. Right? P1. Now, on upper left hand side, what we will write? Multiplicity. What is the formula for multiplicity? 2s plus 1. What is the value of s? Half. 2 strikes. 1 plus 1. What you will get? Sorry, here s value is 0. 2, 0 plus 1. So multiplicity is 1. So I am writing 1 here. Now similarly for s is equal to 0, let us take the second L value, 2. Now J value, L plus or minus? Yes. If we do plus, 2 plus 0, 2. If we do minus, 2 minus 0, 2. So J value is 2. Now 2 means what? D. Okay. I am writing capital letters D, F. D. What is the J value? 2. And what is the multiplicity? As usual, s equal to 0, so 1. Similarly, let us take the L equal to 3 for s is equal to 0. Now J, L plus minus s. So J equal to 3. 3 plus 0, 3. 3 minus 0, 3. So now L equal to 3 means what? F. So F, first you write the J term as subscript on a right hand side. Now next multiplicity as a superscript on a left hand side. Multiplicity again s equal to 0. So 1. So this is the singlet terms. Now next let us move for triplet terms. Triplet terms. So s is equal to, for 1 we are considering the same process. L is equal to first 1. 3 values are there for L. First L equal to 1. Then for S is equal to 1. L equal to next value 2. For S is equal to 1. L equal to 3. First J value. First you do plus. 1 plus 1, 2. Maximum value 2. 1 minus 1. Minimum value 0. So possible values 0, 1, 2. Right? Now here what is L? 1. 1 means what? P, the spectral notation. Okay. How many values are there? Triplet. 3 values are there. P, P, P. Now J value we will write here 0, 1, 2. And what will be the multiplicity? 2s plus 1. S value 1 we are saying. 2 plus 1, 3. Multiplicity is 3. Now next let us go for this. Now J value. First 2 plus 1 maximum value 3. Next minimum value 2 minus 1 1. So the possible terms 1, 2, 3. So now L equal to 2 means what? D. 3 terms are there. First I'm writing the J value. Right? Then multiplicity as usual 3. Now next here the maximum value for L equal to 3 and S equal to 1. 3 plus 1, 4. Minimum value 3 minus 1, 2. So 2, 3, 4. And here L is 3. 3 means what? Spectral notation. F. 3 values you got. First I am writing this J values as a subscript on right hand side of the spectral term. Now here 3 and here 4. Then we will write the multiplicity here. So in such a way we will find the spectral terms for 4p and 4d by using LS coupling. So diametrically also we can show this. How we will show? 4p, 4d. First, S is equal to 0. Next, S is equal to 1. Right? For S is equal to 0, how many values you are having? See here, 1p, 1d, 1f. Okay? 1p, right? 1 second. Okay, 1p, 1d, 1f. Right? This is 1p1. Next, 1d2. Next, 1f3. Now here 3 terms are there. You see. So first, what is there? 3p. Okay. Next, 3p, 3d. Next, what you will have? 3f. Alright. Now first, for 3p, again you are having 3 spectral terms. First one, 3p0. Second one, 3p1. Third one, 3p2. Again for 3d also we are having 3 terms. First one, 3d1. Second one, 3d2. Third one, 3d3. Here also again you are having 3 values. First one, 3f2. Second one, 3f3. Now third one, 3f4. In such a way we can show it diametrically also. Now this is about LS coupling with one example how to find the spectral terms. Okay. Now next, let us go for JJ coupling. So coupling between the J values. Actually, compared to the interaction in LS coupling, the interaction between the two, the combined effect of L and S will be more stronger than the first one. So such as, how we will write means, first we will take such J1 as for first electron L1S1, second electron L2S2. This combination will be strong. Next J2 for first electron L2 for first electron. Now for second electron L2S2. For third electron L3S3 plus so on. Okay. Now how we will write the total J as the value of this J1 plus J2 plus J3. So this interaction will be strong compared to the LS coupling interaction. Okay. Now here this we call it as JJ coupling. Okay. Now similarly, same in case of 4p and 4d, let us find the spectral terms using JJ coupling. Right. Now first, let us take in case of p and d, both are there here. Now first for p electron. For p, L1 will be what will be? So L value spectral notation. 0 means S, 1 means P, 2 means D. Right? Now P means what? 1. Okay, so L1 is 1. Now S value, spin value, half. So now the maximum value 1 plus half 3 by 2. Minimum value 1 minus half 1 by 2. Right? Now similarly for D electron, D means what? 2. So L2 is equal to 2. And spin value as usual half. So J2, the maximum value 2 plus 1 by 2. How much we will get? 5 by 2. And minimum value 2 minus 1 by 2. How much we will get? 3 by 2. Right? 2 minus 1 by 2. 4 minus 1 by 3. 1 by 2, that is 3 by 2. Okay. So now let us write the J1, J2 combinations between these two. How we will write? 1 by 2, 3 by 2. Next, 1 by 2, 5 by 2. Right? Now next, 3 by 2. Here in D, 3 by 2. Next, 3 by 2, 5 by 2. These are the JJ combinations. Right? The J values. Now, combinations I wrote. Now I am writing the total J values. First, I am writing the J value for 1 by 2, 3 by 2. First, 1 by 2 plus 3 by 2, 4 by 2. 3 plus 1, 4. 4 by 2 means how much we will get? 2 we will get. Now next, 3 by 2 minus 1 by 2. 3 minus 1, 2. 2 by 2, 1. J value 1 by 2. Once we added, next we subtracted. Similarly for 1 by 2, 5 by 2. J values 5 plus 1, 6. 6 by 2, 3. 5 minus 1, 4. 4 by 2, 2. 2 comma 3. Similarly for 3 by 2, 3 by 2. The J value. First value, minimum value, 3 minus 3, 0. 0 by something, 0. 3 plus 3, 6. 6 by 2. What you will get? Here we are doing in such a way. LCM 2. So answer will be 0 comma. The maximum value is 3. So possible values will be 0 comma 1 comma 2 comma 3. The possible values. Similarly the last one 3 by 2, 5 by 2. First you do the minimum value 5 by 2 minus 3 by 2. 5 minus 3 how much? 2 by 2. 1. Next, let us write the maximum value. Plus 3 by 2. 5 plus 3, how much? 8 by 2, that is 4. So, 4 means the possible values 1, 2, 3, 4 are the possible values. Now, let us draw the complete splitting diagram. Splitting diagram. Right? Now, how we will draw the diagram? 4B, 4D. So, how many combinations? 1, 2, 3, 4 combinations are there. Right? First, I am drawing the diagram. First one is 1 by 2. Sorry, comma, 3 by 2. 1 by 2, 3 by 2. Okay. The next one, 1 by 2, comma, 5 by 2. Okay. Now, next one. What is this? 3 by 2, comma, 3 by 2. And last one, 3 by 2, comma, 5 by 2. Now, first, 1 by 2, 3 by 2. How many J values are there again? Only 2 J values are there. So, what are they? 1 and 2. Right? 1, 2. Now next, for this 1 by 2, 5 by 2, what are the J values? 2 and 3. Now next, for 3 by 2, 3 by 2, how many J values are there? 4 are there. So 1, 2, 3, 4. What are that 4 values? 0, 1, 2, 3. Ground state, excited state, higher energy state. Now for this also 4 are there. First let us draw the ground state. 1. Next higher energy level. 2. Next excited states. 3. Higher energy levels. 4. Right? In such a way, we will draw the spectral terms diagram, the complete splitting diagram. So this is about the spectral notations and coupling schemes. Thank you for watching my video. If you like my video, share it, subscribe it. Thank you.